So I want to prove to you that saying person here actually puts this person on the stack instead of a 4-byte reference. So I'll go up to public here and I'm going to make a constructor. And of course I just typed public instead of person because I said public while I was typing. Anyway, much like other languages, we have person here. I am going to insert a trace statement so that we have proof that execution came through here. And so what you're going to witness is when main executes, so the first thing it does is declare this person variable. And in order to create a person, we have to execute person's constructor. And so we'll see the constructor execute. So F11 to start the debugger. I could also use F10. The difference between F10 and F11 are a little different, but for this demo I have to use F11 because I wish to step into the constructor. F10 will step over the constructor. If you're familiar with step into and step over, then that makes sense. Otherwise you'll just get used to it as we go along. So F11, so here we're going to declare a person class. So F11, we come up to the person constructor and we run. I'm going to F10 over the cout just in case it wants to take me into a bunch of complicated code I don't want to see. F11 again, and now we see that the output has the person constructor trace statement that I inserted. So F10, and let's just pretend like we don't see this. Basically a bunch of cleanup code. I'll hit F5 to let it run to completion. So sorry about all the hotkeys there, a lot of hotkeys. Another thing, you can do this in other languages, but this also stresses the point, I believe, a little bit. I'm going to insert another level of scope, and generally the time you would see this is in some loop structure, for example, while true, or a for loop, or an if statement. But you can actually just introduce new scope with curlies, and you can nest these as deep as you want. So going here, I'm going to say cout after the scoped block, and let's end line there, and I'm going to cout before the scoped block, and let's run this again. In fact, I'm just going to hit Control F5, just let it run uncontrollably, and you see that the constructor executed between the two trace statements. And you may think, well, you know, those curlies didn't add any value here, because if I took the curlies out down here, we would still get the same output. Well, let's add a destructor, which in C# they were originally called destructors. Now they're called finalizers. Java calls them finalizers. C++ they're called destructors, and there is some difference between the ones in C++ and the other languages. We'll see a little bit of those differences here, and then we'll also explore that later. But anyway, let's put a trace statement here for the person destructor. And a destructor's job is essentially to clean up anything that needs to be cleaned up in a class. So now I'm going to Control F5 this. Build started, build succeeded. We see before the scoped block, we see the constructor runs, and then we see the destructor run before this last trace statement. So essentially, when execution hits this last curly, anything that was declared on the stack in the scope is retrieved again. And in order to retrieve the RAM that a person object takes up, one of the steps of doing that is to run the destructor. So we saw that. If I take the curly braces out, the output changes. We'll see that after the scoped block and the destructor trace statement swapped places. And that is because the person object we declared here was not cleaned up. C++ didn't clean it up until it hit the closing curly of main, because this is now person, this instance of person's scope. So notice I didn't call new anywhere. We have basically an object on the stack. Its RAM is on the stack. It takes room on the stack. I could very well put it on the heap by calling new, but C++ has some different syntax and semantics for that I will introduce in a later video.